In problem number 2, we're given this linear function and we're asked to find, if any exist, the critical values. I'll just write CV for critical values. Now, critical values, these are values at which the derivative is 0 or undefined. Now, the derivative being 0, I'm going to draw that right in here. The derivative being 0 means we have a horizontal tangent line. So we could get these maximums, we could get these minimums, but we also could get these, I'll call it a terrace point, because this kind of reminds me of a terrace. But here, over here, horizontal tangent line, the slope is 0. We've got a maximum. Here, tangent line is horizontal, slope is 0. We have a minimum. And here, even though the derivative is 0 with the horizontal tangent line, we have neither a max nor a min. Now, where the derivative is undefined, that's going to be things like this, where we're going to get these corner points where there is no unique tangent line. So we could get things like this, cusps or corners, things like this. So derivative being 0, we're going to get these smooth max mins or terrace points. Where it's undefined, we're going to get these possible max, a possible min with something that looks like this. So let's see what we've got for our function here. So f of x is that 3x minus 2. Now, you recognize that as a straight line. Straight line's always going to be, well, look at that slope. The slope's positive. So this line is always increasing. So we don't expect to see any max or mins, but let's test it. So let's find the derivative. So f prime of x is equal to 3. And then you ask the two questions. Number 1, where is f prime of x equal to 0? Right, that's going to give us these smooth max mins or terrace points. But 3 is never equal to 0, so there's none of these. Right, we aren't going to get any of those. The second question is, where is f prime of x undefined? And f prime of x is 3. That is always defined, so it's never undefined. So we don't get any of these, right? Not that one. We're never going to get any of these types of things, cusps or corners. So we don't get any of those. So there's no critical values. So f of x has no critical values. And I think the way we're supposed to answer the question is, critical values do not exist. So I would answer this question like this.